Hello there, and welcome to today's session of probability. This question is under ordinary level mathematics for grammar and technical schools. The question says, what is the probability that a letter chosen at random from the letters of the word, this is the word here, is a vowel? So basically, they're asking us to find the probability of choosing a vowel from here. We're going to count the number of letters that are in here and determine the size of the sample space. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So the sample space, we will say there are 11 letters. Our sample space is equal to 11. Now they're asking us to find the probability that if I drag or pull out any letter from here at random, that letter should be a vowel. So we need to count how many vowels are in here. This is the first vowel, the second vowel, the third vowel, the fourth vowel, the fifth vowel, and the sixth vowel. So the vowels in there are A, that's the first vowel, E, O, I, A, and U. Now, if these are the vowels that are in here, then the number of vowels are 1, 2, 3, 4, 5, 6. There are 6 vowels. So the probability, the P of finding a vowel, P of vowel, or the probability of getting a vowel from this word is equal to the number of favorable outcomes. How many outcomes in there will favor a vowel? There are 6 outcomes in there, or 6 possible events that will favor a vowel. There are 6 vowels in there. So we will put 6 vowels divided by the total number of outcomes, or the sample space. How many letters are there in total? There are 11 letters there in total, divided by 11. That's the probability of finding a vowel at random in this. Okay, so the second part of the question says, find the probability that a letter chosen at random from the letters of the word in question 1, this same word above, is a consonant. Now, there are 2 ways of doing that, and we'll use the first approach, being understanding the concept of the complement of an event. The complement of an event, P of A, so if I'm saying P of A means find the probability that A will happen. But if I was to say P of A with a C at the top like this, I'm saying find P of A complement, which means find the probability that a certain event A will not happen. And the formula for this is equal to 1 minus the probability that the event A is going to happen. So in probability, the probability that an event will happen plus the probability that that event will not happen is equal to 1. What do I mean by that? On this coin here, a coin has 2 sides. A coin has a head and it has a tail. So if I was to say, if I flip this coin, if I toss this coin, what is the probability that the coin lands with a head facing upwards? We would say the probability of a head, P of head, is equal to, on this coin you have just one head, divided by the total number of sides on this coin. You have 2 faces, the tail and the head, 1 on 2. What if I was asked to find the probability that a tail will show up if I was to flip this coin, the probability that it will land with a tail like this? Well, I could simply say the probability of a head showing up and the probability of the head not showing up is equal to, so I can say the probability of a tail is equal to 1 minus the probability of the head showing up. So if a head is not showing up, then whatever should be showing up is a tail. So the probability of a tail showing up is equals to 1 minus the probability of a head showing up. And this probability of a tail showing up is the same as the probability of the head not showing up. So the probability of a head not showing up is the same as the probability of a tail showing up. Now let's apply that to our question. So what is the probability of you having a consonant? Well, if I know the probability of having a vowel, that gave us earlier, we had 6 on 11, I can say that the probability of not having a vowel, is equal to 1 minus the probability of having a vowel, which is 6 on 11. So 1 minus 6 on 11. That should give me 5 on 11. That's the probability of not having a vowel. We call it the complement of the probability. But then the probability of not having a vowel is the same as the probability of having a consonant. Because in any set of letters in the language we use, if I'm not having a vowel, then I'm definitely having a consonant. So the probability of not having a vowel, the probability of not having a vowel is equal to the probability of having a consonant, of having a consonant. That's one way of finding the probability of having a consonant. Now, another way of doing it is that we can also count the number of consonants that are in this word here. The consonants up here are 1, the letter B, 2, letter K, 3, letter R, 4, letter T, and 5, letter L. So there are 5 consonants up there. We have B, K, R, T, and L. The number of possible outcomes or possible consonants are 5. So we can say the probability of having a consonant, P of consonant, is equal to the number of outcomes that will favor a consonant, or the number of consonants, that's 5, divided by the total number of letters in here. And we counted that earlier, and the sample space gave us 11. So that's 5 on 11. So you see that using this method gives us the same answer as using the method of the complement of the probability.